This video will describe how to value a portfolio of one share of a stock and one put option. Sometimes this is called portfolio insurance. So we've got here the geometric Brownian motion model that we use for the Walmart stock valuation. We recall used the volatility for 2021 based on the standard deviation calculated for 2021 and got a very close value for the call option, which seems to indicate that this volatility is being priced in. Our put option payoff was a little bit less than the market, but because we've got the right volatility, this should allow us to go ahead and have an idea how this portfolio of a stock option, a put option, and a share of stock could benefit the investor, because we've got a reasonable model that's capturing the volatility that's probably being priced into options. So the first thing we'll do is just value an investment in the stock. And so this is pretty simple. An investment in the stock, if we purchased it today, would be valued at the ending price minus the beginning price. And as with all cash flows here, we will discount those, in this case using the risk-free rate because we're holding the option. So that would be equal to the exponential function with a negative and the time to expiration times the risk-free rate. So that'll be an investment in the stock. And we'll make an output cell in at risk for that investment. Then we'll also value the investment in the stock plus the put. So this will simply be the investment in the stock plus the put option payoff minus the put option price. Now here, we could set this portfolio up with either the market price or our simulated price. Because we're choosing to simulate here the results of this portfolio, we'll go ahead and use the simulated price. We're close enough here that this should still give us a good idea of what the payoff might be for this portfolio. And recall that this put option payoff is discounted. And so that means all the cash flows here, including the investment in stock, are discounted. The discount rate is not terribly significant because the risk-free rate's so small. Technically, the right thing to do is to discount all these cash flows. If we wanted to remove the discount factor, in this case, because the risk-free rate's so small, we would get about the same idea of what's happening. So we'll go ahead and simulate this, and we'll use 10,000 trials. Okay, so here are our results. Here is the investment in the stock plus the put. And the thing to notice about this is the mean payoff is very small, 3 cents, very close to 0. The standard deviation of the payoff is about 9.91. If we go to the investment in the stock, again, the mean payoff's very small, about 3 cents, but the standard deviation is higher at 16.52. So when we hold the stock in combination with the put option, we get about the same average payoff, but with a lower standard deviation. We could also see this as part of an overlay chart in at risk. Let's create a new overlay. And the simulated cells that we want to overlay are the investment in the stock, comma, the investment in the stock plus the put. And so we can see this overlay. And what we see here is all of the blue values are related to the investment in the stock, whereas the red values have a lot of values here right about at about a -7, because that's the cost of the put option. So the put option cuts off all these highly negative values, and that's why sometimes this is called portfolio insurance. So that is one possibility for using options as part of an investor's portfolio.